Hi, I'm Brad Gainer, co-founder at Lexumo, and I think I'll start with a little story, a little hypothetical story. So, it's that time of year again, Super Bowl's coming up, it's time to go big. We're going to go 70-inch TV this year. So we borrow a van from a friend, and we drive down to Best Buy, we go to the store, and we pick it out, and we bring it home. We plug it, we put it on the wall, plug it into power, and what do we do next? Give it the Wi-Fi password. Because the TV is a smart TV, and it's got a camera, and it's got apps, and it's got features coming in 2017. They're all software. And how secure is that device?
Not very.
Not very.
Yeah.
Not very. So what happens when someone logs into your TV and turns the camera on while the TV appears to be off and starts streaming your video out from your living room into the rest of the world? And it's a terrifying thought. And the companies that make these devices are starting to wake up to this. They're putting AppSec managers in charge of devices. Because let's step back now and figure out what happened, right? Well, this company, major electronics manufacturer, built, set up a product team, and they got to work, and they just had a deadline. So they went out and grabbed lots and lots of free open source. They got operating systems and codecs and apps and cloud stacks and secure comms. They're secure, it's open source. And they put it all together as fast as they could. And they were, open source is great, right? They got all this capability and they got it together fast and they got it out. And they got it to market. And where did that development team go? Well, they went on to the next product, right? And what happened with that open source? Well, Heartbleed happened, Drown happened. Hey, the glibc vulnerability, where is it? We don't know. So the open source community maintains all these projects. That's really valuable work. But the consumers of this code, how are they getting the information? And it's not as simple as, well, we'll just update it to the latest because, hey, it was free open source software the day you took it off the shelf and installed it. But the moment you started building that into your product, you invested in it and you own the maintenance costs. So what Lexumo does is goes out and grabs all the world's open source software, all the packages, all the versions, all the code that was ever written in open source, and we make it all searchable. Right? We don't make it searchable to you. We make it searchable to us. We take your code, a vendor's code, and we make it searchable and find all of the open source components that they're using, not just the packages that the code purports to be, but the very specific elements of those packages that are actually being used in that product. We detect all the versions, the code they're using, the code they're not using, and we correlate that to vulnerability databases so that we can tell those vendors what they should be worried about. And we look ahead into the future versions of these projects and extract the patch and tell them how to fix the problems. And we do that during development. So we work, we plug into the development workflow at build time, at either the Git repository or the build system. We plug right in, extract either source or object code, depending on the type of vendor and what they're willing to share. Ship that up to our SaaS platform, do all our analytics in the cloud, and tell them the answer. Here's what you have, here's where you're vulnerable, here's how to fix it, and they can just push those back as Jira tickets back into their workflow. But because our techniques are making code searchable, it's all search, it's all indexed. And so when new vulnerabilities emerge, when that product team is 3 products later, and hey, glibc hit, who has it, who's vulnerable? Our customers wake up in the morning with an email that says, this thing affects you. Here's where it is in your product. Here's how to fix it. And luckily, some of our customers get alerts that say, hey, you're not vulnerable. You didn't build this piece of it into your product. You don't have the server code in your SSL, so you don't have Heartbleed. You don't have, you took this out, you changed something that makes you not vulnerable. So platform's live. We're working with about a half dozen early access customers. So here's a scan of Yocto. And this was Yocto, the Dora distribution of Yocto. And we just pulled it off the repository, ran it through our tools, auto-detect all the packages that are subcomponents of Yocto, Yocto Dora. And sure enough, this stuff ages out over time. So these packages most likely weren't vulnerable when they were first put into the distribution, but they are now. And if you look at them, you can see exactly which ones have vulnerabilities, where they are. For every vulnerability, we generate a ticket, a vulnerability card, that identifies the vulnerability and how to fix the problem. All right, how'd I do? Thank you for my extra 30 internet seconds. Questions up front?
So, how do you know how to fix a problem?
Yes, that's a great question. How do we know how to fix problems? So the open source community is great, right? They continue to work most of the packages that are in use today. Codecs, comms libraries, and they discover vulnerabilities, and they typically release patches at the time that they release the vulnerability information. We look ahead to the future version of the code that our customers are using and extract the patch from where the code is fixed in the open source and provide that back to our customers so they can apply the patch in a way that keeps them consistent with the open source package, which is very important because in time, they can choose to do a planned upgrade at a later date.
You specify embedded on your webpage. I was just wondering why is this specific to embedded? Like, wouldn't this be applicable to other?
It will be. So everyone starts somewhere, and our initial market is embedded systems, Internet of Things, so connected devices, in large part because we have excellent C and C++ support. So we basically handle most of the code found in connected devices today. We're adding Java next, and it'll be ready at end of Q2. And we will move beyond embedded, probably the back end to the embedded devices next.
I'm guessing you sell it by running their code through it and saying we've identified these vulnerabilities. If you want to know the details, we need to talk.
Yeah, so for large companies that are seriously evaluating it, we'll give them the answer because they don't have just one product. They've probably got 10, 100, 1,000 products, and we're more than happy to help them and show them the value for the first one completely. For downstream, we may limit the amount of data just because so much of our value is immediate. But we really firmly believe that the continuous nature of what we do, the alerting, the keeping people secure after that initial development is done, is just a critical part of what we're doing. We plan to keep the world's open source software secure. And so there's some reason to get people to have some patience and experience that over time. Please, do that.
I would be a customer, for instance, of a large company. I have a heating system, say a Honeywell heating system, and how would you protect me? You might protect Honeywell, but how would you protect me?
Yeah, so we are a business-to-business company, business-to-business SaaS platform. And so put me in touch with Honeywell, and we'll make sure that their code doesn't have open source vulnerabilities in it. It's not really feasible to have, except for the maker community, to have customers hacking their OEM devices to try to install their own security patches.
But anyone could get into my system. I mean, if I have a toaster.
And you should only buy from vendors that are Lexumo certified.
What is your competitive landscape look like?
So there are some legacy solutions out there where there's some companies that will scan code and tell you what your code purports to be, right? So this looks like a package. It has a version string of a package. It smells like version something. It has some SHA matches, right? Some fingerprints of the package. Or it has a binary fingerprint that looks like a package. And they'll tell you what your code purports to be. They will tell you that it's out of date. They will tell you that it's vulnerable, and they will tell you that you should upgrade. And there are some customers that's good enough. I'm just going to use stock code off the shelf. I'm going to always upgrade the latest version. So we can compete with them there. For those customers that actually invest in their products, take the open source code and invest in a product, turn it into something that's more than the sum of the parts, have changed it, reduced the code headroom, customized it, locked into the APIs, invested in that code base. They need something that actually can tell them what they actually have and how to fix it. So whether it's in the embedded systems or in the enterprise, when something bad happens, how do I fix it as quick as possible and then get my planned upgrade done at a later date? That's where our solution shines. Please.
So for vulnerabilities that don't have patches yet,
early release first stage, are you doing notifications, or are you waiting till you have something to actually fix for them?
So right now, we're primarily focused on providing open source vulnerabilities to open source software users. And those vulnerabilities are almost always released in conjunction with a patch or an update. So that hasn't been a major issue. But we are planning on adding, so a big part of our value proposition is having a curated database of vulnerabilities that's much more comprehensive, complete, and accurate than what you can find in the open source community. And as part of that, we will add additional sophistication around the patches as well.
All right, thank you, Lexumo.
Thank you.